Do you count, or are you meaningless? That's the mystery of life. Part 2. How to count, how to add. Before making crazy calculations, we need to have numbers to operate. To represent a number, we have to represent each digit within a single column. This means that for the number 2018, we need an 8 in the first column to the right, the ones column, a 1 in the second column, the tens column, no count in the third, the hundreds, and a 2 in the fourth, the thousands. As you can see from the 8 in the example before, it is represented with an upper bead touching the beam, which means 5, and 3 lower beads touching the beam, each one meaning 1. Therefore, 1 times 5 plus 3 times 1 is equal to 8. This gives us an important clue. Beads only count if they touch the beam. If none is touching the beam, that column counts as 0. Maybe you are asking, and how do I represent something like 3.14159? Then you have to replace the decimal point with 2 zeros, making it 300141159. I don't like this solution, but it's the traditional way of doing it. With that info, guess what numbers are these? 4, 9, 27, 61, 2001, or 2.1, 590, 40,006, 4.06, or 40.6. See, that's what I hate. However, that problem is not as important, as an abacus is made for personal calculations and one is supposed to know what number is operating. Yeah, allegedly. However, ranting through life won't make us move forward. Do you know what will make us advance? A transition! Proper technique. Now you know how to read an abacus, but how to write in it? As you guess, it's moving the beads up and down. But in order to become a master, and as quick as possible without orthopedic issues, tradition says you should use the thumb to move lower beads upwards, and your index for any other movements. And for movements in this video, and to add to our knowledge, addition! The most basic operation of the world is also the easiest in an abacus. It's intuitively simple, so that I guess you already know how to do it, even if you've never touched an abacus. However, my duty is to explain it to you, but beware. It's one of those things whose explanation is more complicated than the actual thing. First, we are going to explore addition of one-digit numbers. For practicality, we are going to call the first number A, the second B, and their addition C. It doesn't matter the size of A in comparison to B, as long as A and B are one single digits. This is because of the properties of addition. To begin, express A in the abacus. Then, if both A and B are less than 5 and C is less than 5, you should only move upwards the corresponding beads of B from the lower deck. If one of the two, A or B, is equal or more than 5 and the other is less than 5, and C is less than 10, you should move the corresponding beads from both decks. If A and B are less than 5, but C is more than 5, you should look for a number x such that B equals 5 minus x. After that, you should push down the bead of the upper deck and also push down x number of beads from the lower deck. Let me show. This is basically borrowing in a base 5 system. And talking about borrowing, if your sum is greater than 10 in the rod, you should add one of the rod directly to the left and remove x beads, being x the solution to B equals 10 minus x. If this part confused you, this is simply what you do when borrowing with our numbers. All these conditional operations are summed up in these tables. However, you do not need to memorize or understand the mysteries of the universe to add. That's the magic of Abacus. You can see what you're doing, and you're being guided by your instinct. So, this video in a nutshell. Upper deck counts as 5, lower deck as 1. Everything else works as our usual numbers, and follow your guts. The force be with you, my little Padawan. See ya.